Hello ladies and gentlemen, my name is Mr. TSEBE and today we'll be doing session 3 of our Laplace transform. So suppose that they gave us something like this, Laplace transform of t squared, and they're asking us to evaluate. So in order for us to evaluate, we start off by writing our formula, which is the limit of b which goes to infinity and b 0 e minus st ft. Our ft in this case is t squared dot dt, like that. So that is our formula. That is what we're gonna use. So we have to see that we have to actually integrate using the integration by parts. So our formula goes like this: u dv equals to u times v minus v du. So in this case, our t squared equals to our u. We are going to let our t squared to be equals to our u. So if we integrate this and then we also integrate this, this is the same as 2t, but this one is the same as du over dt. So if I multiply by dt and then if I multiply by dt in this case, so we can see that my du equals to 2t and dt. That is my du. So what is my dv? My dv equals to this exponential function, which is of t and dt. So in this case, our s is constant. So if we find the integration of the dv, if we integrate dt, so if we integrate here, no need to put the limit because of we are going to put it on this equation. So this one you just integrate it like that only. So if we integrate this, it will give us minus e minus st all over s plus c. This is integrated. So we can actually substitute on our equation. But what is our equation? Our equation is a u. What is our u? Our u is actually t squared. So our u is t squared multiplied by dv. But what is our dv? Our dv equals to this portion. So it will be minus e minus st dt equals to u. Our u is t squared multiplied by our v. Our v is minus e minus st all over s. And then our limit is 0 to b minus. This is our integration. We are substituting here now. What is our v? Our v is minus e minus st all over s multiplied by du. But what is my du? My du equals to 2t and dt. Equals to 2t and dt. That is my du. So let me erase this part. Let me erase this part. So don't forget that we are actually evaluating Laplace of t squared. So this will be the same as, if I can substitute this limit here, it will be what? On t squared, it will be b squared multiplied by minus e minus sb all over s minus, and minus this again, minus e minus st, in this case is 0. We are going to substitute 0 here, and then our s, but this is multiplied by t squared, which is 0 squared in this case, minus this part, which is our integration of which starts from 0 all the way to b or to infinity. So it will be 0 to b. So negative times negative, it will give us positive in this case. So I can take 2 over s I can take 2 over s outside. I can take 2 over s. So if I take 2 over s, I will be left with minus e minus st times t and dt. That is what I'm left with. So as b approaches infinity, this thing approaches 0. So the whole thing will just be 0 according to our first session. Negative, negative, positive. 0 multiply anything is just 0. Plus 2 over s. The integral of minus e minus st dot t dt. So we must integrate here by parts again, because if we just want the integral of e minus st, that's what we want. So we have to integrate by parts again. Hence our formula. Our formula will just be b0 minus est dot t dt u times v minus this integral v dot du. So we are going to let 2s, we are going to let 2 over s to be our equation 1. So 2 over s will be our equation 1. So we want to focus on this function, on this part and not 2 over 5. So again, I'm going to let u to be equals to t. So but my du equals to my dt in this case. I'm sure you've seen this one on our first session. So our dv will also be e minus st dt. Even this one, we have seen it on our first session. It was minus e minus st all over what? All over s plus c. So that is what we are having actually. That is what we are having actually. So I will erase here. I will erase this part. So I can just let this whole thing to be my equation 2. So the integral of 0 b e minus st dot t dt to be my equation 2. To be my equation 2. So let's substitute this on our formula. Let's substitute on our formula. So our formula, we are going to be having b0 e minus st t and dt. So what is my u? My u in this case is t multiplied by what? Multiply my v, which is minus e minus st all over what? S, and then our limit is from 0 to b, minus the integral of 0 to b, which is e, which is v. What is my v? My v is minus e minus st all over s times du. But what is my du in this case? My du is the same thing as dt. I can make this my equation 2. Let me make that one my equation 2, which is also that one. Or let me evaluate first. So let me erase this part now. Let me erase this part. So if I substitute here, if you try by substituting here, b, this thing will give us 0 for b, and then even for 0, it will give us 0. Try substituting on your own, you will see this whole thing is just 0. Minus b. So minus is just the same as positive, and 1 over s. And then this will be e minus st and dt. So this is basically what will be. This is basically what we'll be having here. So let us integrate this. So it will be 1 over s. So the integration of this is minus e minus st all over s. And then our limit is from 0 to b. So which is 1 over s. So minus e minus s, if I substitute b over s minus and minus again, minus e minus s 0 over s. So this thing will give me 0. I've already explained for that one. So this will be 0 plus negative negative plus. Anything raised to the power 0 will just give us 1. So it will be 1 over s. So 1 over s times 1 over s, it's 1 over s squared. This is my equation 2. This is my equation 2. So let me erase this part. That was my equation 2. So Laplace transform of t squared equals to equation 1 multiplied by equation 2, which is 2 over s times 1 over s squared. 2 times 1 is just 2. S times s is s to the power 3. So thank you guys. This leads us to the end of our session. And if you enjoyed, please subscribe and share with your friends. Thank you so much.